Welcome back to the channel, guys. Hope you're doing extremely well, and this is your very own mass coder this side. And in this video we are going to discuss an important question of binary search tree. 96 problem of the lead code, unique binary search tree. What does the question say? The question says that you have been provided n as your input and you have to return number of structurally unique, please, I cannot emphasize more on it, structurally unique BSTs which has exactly n nodes which are numbered from 1 to n. That is, if n is equals to 3, you have 3 nodes, 1, 2, 3. If n is equals to 4, you have 4 nodes, 1, 2, 3, 4. Alright? Okay, and you have to give me the number of, okay? You have to give me the number of structurally unique BSTs. How will you solve this problem? So, an input example is given to you for n equals to 3. These are the five structurally unique trees you can form. How they are forming? Let me give you a glimpse. So for n equals to 3, what are the number of nodes possible for me? 1, 2, 3, right? So suppose I make 1 as my root. I make 1 as my root. Because 2 and 3 are both greater than 1, 2 and 3 will lie here. There are two possible ways of doing that. One, if I make 2 as its immediate right. If 2 is here, 3 has to be here. Other possible one is 1. If 3 is the immediate right, then 2 has to go on 3's left, right? Okay. If I make 2 as my root, only one possible structure, 1 here, 3 here, because 2 is the mid, 1 has to lie on the left and 3 has to lie on the right. Okay, the position cannot be interchanged. If 3 is my root, what will I do? 1 and 2 both will be lying on the left side. Now again two cases. One is here, and if one is here, 2 will come here. But if 3 is here, 2 is the immediate left, then 1 will also come on the immediate left of 2, right? So you can see this is my tree number, this is my tree number 1, this is my tree number 2, this is my tree number 3, this is my tree number 4, not 4, this one, tree number 4, and this one is my tree number 5, right? So as you can see, output is 5 because I have been able to make 5 structurally unique. What do I mean by structure? You can see that this is like this is like this is looking like this is looking like this, and this is looking like this. All the structures are different. I don't care about the values inside it as long as they're BST. I only care about their structures, right? Values don't matter. Values don't matter, but they should be a BST. Okay. Now, how will I solve this problem? See, the problem is actually complicated for n equals to 3. I am not able to derive at the conclusion of why n equals to 3 is giving me 5 nodes. How can I make a relationship between them? So let me simplify the test cases. That is the only thing I can do. So suppose I have got n equals to 0. That is, I have got no node. I have got 0 number of nodes. Now what will you do? If you have 0 nodes, isn't possible to make only one structurally unique BST. You will say, how one? I am saying empty BST. A value equals to null is also a BST. You have to agree with me right here. Okay. Moving on. If n equals to 1, if only one node is present, what is the one node present? Only one. Only one is possible, right? Only I can place this node only. Okay. Moving on to n equals to 2. Okay, moving on to n equals to 2. How will I solve this problem? So I have two nodes, 1 and 2. Now if I make 1 as my root, 2 will only come on the right. If I make 2 on my root, 1 will only come on the left. So you can see one tree is this, second tree is this. N equals to 2, I have two nodes. For n equals to 3, what will happen now? For n equals to 3, I actually saw 5 nodes. For n equals to 4, you will be seeing that what I am doing. Just give me a minute. For n equals to 4, now the problem is actually complicated, because for n equals to 3, I was able to make 5 unique, structurally different unique trees, right? For n equals to 4, the number would be even bigger. How will I solve it without any confusion? So let me try it out. So I have 4 nodes, 1, 2, 3, 4, right? Any of them can become the root. So suppose 1 becomes the root. As soon as 1 becomes the root, as soon as I decide that 1 will become the root, isn't it true that these 3 nodes will lie on the right? These 3 nodes will lie somewhere in the right subtree, that is 2, 3, 4. If I make 2 as my root, it is quite easy to say that 1 will lie on the left and the rest 2 are lying on the right. If I make 3 here, then 1 and 2 will lie on the left and 4 here. And if I make 4, then 1, 2, 3 all will lie on the right, on the left, and right will be actually empty. You have to agree with me only here. This is the point that you have to realize, that if 1 is here, 2, 3, 4 are going to lie on the right. If 2 is here, 1 will on the left, 2, 3 and 4 on the right. These are the three things, these are 3 to 4 things that you have to just agree with me. Okay. Now moving on. If I get the number of unique, structurally unique binary search tree arising from here, what I'm saying is you have 2, 3, 4 in your hand, right? You have 2, 3, 4 in your hand. Can I say, for assumption, treat them as 1, 2, 3, treat them as 1, 2, 3, treat them as 1, 2, 3. If they are providing me, if these three nodes are providing me x number of unique, structurally unique binary search, x number of BST, will 2, 3, 4 also provide me x number of BST? I am saying the number, I am saying n of 1, 2, 3 is equals to n of 2, 3, 4. I am saying n of 1, 2, 3 is equals to n of 2, 3, 4. Why? Because I just want the unique binary search tree. Structurally, I say values don't matter as long as they are BSTs. Okay, as long as they are BST, value does not matter. That means 2, 3, 4 can be treated as 1, 2, 3 to find the number of structurally unique binary search, right? To find the number of unique binary search tree. For example, in the case of these 5 trees, you can actually try to put, instead of 1 try to put 2, instead of 2 try to put 3, and instead of 3 try to put 4, and you will see that all these 5 structures will emerge exactly same because they are all BSTs. I'm just attaching these BST on the right of 1. I'm just attaching these BST here. I'm just attaching these BST here, right? Now, because I know that n equals to 3, I have got 5 nodes. This is actually returning me 5. So this is actually also equals to 5. So this is 5 nodes here. So can I say that for 1 as root, I have 5 unique structurally unique trees, right? Now for 2, it is quite easy to see that this one is actually equals to this one. This one is actually equals to this one, right? So for n equals to 1, I have only one node. I will be doing 1 from here. But for 3, 4, can I say that I want to treat 3, 4 as 1, 2. I subtracted 2 from 3, I subtracted 2 from 1, 4. So 1, 2 I have, right? Same logic as it was applied here. The logic is exactly same. 3, 4 reduces to 1, 2. That is n equals to 2. This is returning me 2 nodes. This is returning me 2 nodes. Now, there is a logical steps. So I am saying, suppose you have a root and the left subtract is returning you 3 nodes, 3 unique binary search tree, right? So x equals to 3 here, and it is returning 4. Suppose the 3 are named as A, B, C, and they are D, E, F, G. How many unique structures of binary search tree are possible from this whole combination with 3 here, 4 here? Now, as an engineer, you can say that A can be linked with D, A can be linked with E, A can be linked with F, A can be linked with G. That is, for A, I can pick D, I can pick E, I can pick F, I can pick G. Similarly, for B, I can pick D, E, F, or G. Similarly, for C, I can pick D, E, F, G. So that 4 structures from here, 4 structures from here, 4 structures from here. That is 3 into 4 structures. 12 structures are possible. 12 structures are possible. So what I'm saying is, if 1 is coming from here, 2 is coming from here, I'm actually returning 2. Similarly, 2 is coming from here, 1 is coming from here. So 2 into 1 gives me 2. 3 here. Now we will say there is no thing here. So I can say that 0 nodes are present here. 0 nodes are present here. So n equals to 0 will arise here. That is 1 node. So 3 into 1, 3 nodes are present here. So what is my, so into 3 it is 5. It is 5 because f of 3 is 5. So 5 into 0, 5 into 1 is equals to 1, right? So what is my total sum? So 5 is from here, 2 from here, 2 from here, 5 from here. So my sum is 5 plus 2 plus 2 plus 5, which is equals to 14. That is, for n equals to 4, my answer would be 14. Similarly, for n equals to 5, what will happen now? N equals to 5. N equals to 5, what will happen? I have 1 node, 2 node, 3 node, 4 node, 5 node, right? Now, just mention my steps, just see my steps. My I is actually going from 1 all the way up till 5. Suppose I say answer equals to 0 currently. I say answer equals to 0 and my I is going from 1, you can see 1 and 5 here, right? it is actually giving like my ith node is my root node. I am treating my ith node as my root node, right? So if 1 is root, if 1 is root, how many elements are on the left? How many elements on the left? Suppose this is my n. How many elements are on the left? So you can say 0. For 2, only 1. 3, 2. 4, 3. 5, 4. That is, for each I minus 1 nodes are present on the left subtree, right? Let us treat it as I only. For each right subtree of the I, here right. So for 1, what is actually happening? 2 to 5, that is 1, 2, 3, 4, that is n minus 1, right? For 1, it is n minus 1. For 2, it is 3, 4, 5, that is n minus 2. For 3, it is 4, 5, n minus 3. For 4, it is only 5, n minus 4. For 5, it is 0, so n minus 5. So you can say n minus I, right? N minus I. N minus I nodes are present on the right. So what I am saying is, my answer, my loop will look something like, I will initialize my answer equals to 0. I will initialize answer equals to my 0. And now I can say for I equals to 1, I equals to 1 to n, right? What will happen? Answer plus equals to f of, suppose the function same is f of I minus 1 multiplied by f of n minus I, f of n minus I, and you can simply return your answer. You can simply return your answer. Now, the problem is actually not solved up till now. Here comes a twist. Here comes a twist. I am actually calling recursion, if you can see. This is a recursion. For f of I am actually calling a recursion. Right? The base case of f of I are, if I equals to 0, in that case return 1. If I equals to 1, in that case return 1. These are the base cases. This is a recursion. I am saying, is it possible for me to use DP? Always try to ask more from the problem. Is it possible for me to do the DP here? Let me see. Let me see. So suppose I call for f equals to 5. I equals to 5. I have n equals to 5. So I'm actually calling for f of 5. What will happen? F of 5 is actually calling for, when it will go from I equals to 1 to 5, that is I equals to 1, 2, 3, 4, 5. For I equals to 1, for I equals to 1, it will call for I minus 1, that is f of 0, and n minus I, that is 5 minus 1, that is 4. It will call for f of 4. For 2, it is calling for f of 1 and f of 3. Then f of 2, f of 5 minus 3, that is 2. Then f of 3, f of 1, f of 4, f of 5 and minus 5, 0. Right? These are all the calls that it is making. You can see f of 3 is calling here, f of 3 is calling here. And if you will draw the recursion subtree more and more and more, you can see that many problems are arising. F of 2 is also overlapping, f of 1 is also overlapping, right? F of 4 is also overlapping. So I can say that overlapping subproblems exist. Overlapping subproblems exist. And whenever I see this is true, I say don't think anything else, just apply DP. Just apply DP. So what will you do? You will just create a DP array. Now what is the length? So for n, I want maximum n equals to 5. So I will create a DP length of n plus 1. I will create a DP length of n plus 1. That's all. What will I do? My recursion, my pseudocode will look something like this. That for solve function, I will take an n, right? What will happen? If n equals to 0 or n equals to 1, in that case return 1. If dp of n is not equals to minus 1, return dp of n. These are the two cases. Now what will I do? I will say answer equals to 0 for I equals to 1 to n. What will happen? Answer plus equals to solve for I minus 1 multiplied by solve for n minus I. And now after this for loop, you can say dp of n equals to answer, and you can just simply return them, right? And this will actually solve your problem. This will actually solve your problem. Hope you're clear with it. And now it is time for you to see the code, so please stay tuned. Alright, so here is the coding section, guys. Hope you can see it clearly, and please let me request you to please subscribe to my channel if you are understanding this video, if you are able to grasp the concept, right? So moving on, I will say int answer equals to solve for n, and then you can simply return your answer. We will be applying DP afterwards, right? Let me write down the recursion test case first. So int solve and taking an integer n. Now if n equals to 0, return 0, return 0. If n equals to 1, in that case return 1. Above also it is also 1. Okay, typing mistake. Now I will say int answer equals to 0 for int I going from 1 I less than equals to, don't forget to apply equals to also, I plus plus. What will happen? I will say answer plus equals to solve for I minus 1, because the left subtree will contain I minus 1 nodes, multiplied by solve for n minus I nodes, because the right subtree is containing n minus I nodes. And now you can simply return your answer, right? Hope it will work. Let us try it for sample test cases, then we will apply a DP in it. It is running fine. Let us apply the DP now. So I wanted to create an array of size n plus 1. So vector of int, name it as DP of size n plus 1. Initialize all of them by minus 1. So you can send DP easily here and here. So vector of int and DP. Now I can say if DP of n is not equals to minus 1, that is it has already been occurred. So return dp of n, return dp of n. And now after it, before returning it, you can say dp of n is equals to answer. And also don't forget to pass in the arguments of the recurring test cases, dp here and dp here. Let us try it now. It should run fine, and it is running fine. Let us try it for submit as well. And please do consider subscribing to my channel if you are able to understand anything from this question. If you find it helpful, please do consider subscribing to my channel. So as you can see, it has been accepted, and thank you for watching. We'll meet again tomorrow. Till then, keep coding, stay tuned, and have a nice day.